Bismillah ar-Rahman ar-Rahim. We'll continue. That was the last one we did. Now we'll go to the new problems. This is a little bit different than the ones we did. Now our cross section are isolations, which two sides are equal, right triangles. Okay, so I have a triangle like this, with the hypotenuse in the base. This is hypotenuse. This is same side. Let me call it L and L. Okay, the base is an elliptic region. So I have an elliptic region. Is an elliptic region. And I have, this is the, so this point is X and Y. This one, which is the base, will be 2Y. Will be 2Y. So he said the hypotenuse in the base. So this is the hypotenuse, will be 2Y. Now the rest is just calculation. Okay. This is the hypotenuse. This is the leg of the other two legs, the other two sides, which are equal. Which are equal to each other, or L and L. And this is the right triangles. So from this, why I call it 2Y? Because this is Y and this is Y. If you look at it, look at this X and Y. So this is Y, this is another Y. So that is 2Y. So you have the relation L square plus L square is used for the Pythagorean theorem, since I have a right triangle. It will be 2Y all square. So that means L square will be 2y square. Yeah, 2L square equal 4y square, so L square equal 2y square. Okay. And what is the area of the triangle? The area of the triangle will be half base times height. Half L times L, so half L square, which is y square. So this is my area. That's it. This is what I need, the area. And I have this is the function, 16x square, or this is the ellipse, equal 400. So I have what? 25y square equal 400 minus 16x square. So y square equals 16 minus 16 over 25x square. So I have the area now in terms of x. Okay, perpendicular to the x-axis. I want it in terms of x. So I have it in terms of x. So this is the volume. And that from where to where? X values from this point to this point, which is minus 5 to 5. This will be minus 5. This is 5. So it's from minus 5 to 5. So the volume is from minus 5 to 5. Y square. Y square, which is 16 minus 16 over 25 x square dx. That is even function, so I can make it 2, 0 to 5. 16 minus 16 over 25 x square dx. That gives me 2. 16x minus, what is this? 16 over 25 x cubed over 3. That from 0 to 5. That would be 2. 16 times 5, that will be 80. This one, 5 square will go with this. We have 5 times 16, which is 80 over 3. That gives me what? 2. This is 240 minus 80 over 3, which is 2 times 160 over 3. That gives me 320 over 3, which is this one. Okay. If the base is enclosed area, this, what's cross section? Squares. Squares. So what is the base between what? Let me graph the functions, graph the curves. Y equal 1 minus x, so at x equals 0, it is 1. And at x equal 1, it is 0. So I have this line. I have this line. And y-axis, x-axis. Y-axis, x-axis. So I'm talking about this region. This is the region we're talking about. Okay. Perpendicular to the x-axis. So let me do the base. That will be my base. So the base will be 1 minus x. That will be the base. And squares. So I have the area is the base square. So the area will be 1 minus x square. From where to where? From 0 to 1. Very clear, from 0 to 1. So the volume 0 to 1 of this 1 minus x all squared dx. That 0 to 1, 1 minus 2x plus x squared dx. That give me what? X minus x squared plus x cubed over 3 from 0 to 1. So it's 1 minus 1 plus 1 over 3 minus 0. So it's 1 over 3. Okay. Let me do more problems. Let me try to finish this section. It's a little bit lengthy. I have one solid about the line. Okay. So I have what? X equal y squared. This is x equal y squared. Parabola over to the right. X equal y. This is x equal y. And about the line y equal minus 1. This is y equal minus 1. I'm talking about this one. They have r of y. Now everything should be in terms of x. So I need to change this in terms of x. So I have y square root of x, because I need the positive side of this parabola. And I have y equal x. Okay. What is r of y? Will be the upper one up to the line from here to here. So it will be what? It will be square root of x minus 1 plus 1. And what is small? This is terms of x, sorry. That should be terms of x. R of x will be x plus 1. X minus 1, which is x. So the volume, yeah. Okay. Now, the area will be by integral of what? Of this one. Square root x plus 1 all square minus this all square. So the volume, and it will be from where to where? From 0 to 1. This is 1. So it's from 0 to 1 by times this. Open it. That will be x plus 2 root x plus 1 minus x squared minus 2x minus 1 dx. So it will be by 1 cancel. I can do the derivative. I have x minus 2x, so it will be minus x squared over 2 minus x squared. That will be minus x cubed over 3 2 root x, which is 2x to the power half. So that 2 over 3 x to the power 3 over 2. And that from 0 to 1. So it will be pi times what? Now substitute, I have minus half, minus 1 over 3, plus 4 over 3. So it's very clear I have 1 minus half, that will be half. So it will be pi over 2. This is bad. Okay. By rotating the region bounded by this. So let me graph the curves. I have what? Y equal in x. This is y equal in x. And they have y equal 1. This is y equal 1. This is y equal 2. And x equal 0, which is the y-axis. This is the y-axis. So I'm talking about this region. And they want to make the rotation about the y-axis. Okay. So I want the strip on the line perpendicular to that. It means I need to do it this way. So I need to have things in terms of y, in terms of x, or in terms of y. So x equal e to the power y. Okay. خلاص. And it will be a disk. So r of y will be what? E to the power y. And the area will be pi e to the power y square. So the volume, and that will be from where to where? From the y, from 1 to 2. From 1 to 2. That from 1 to 2 by e to the power 2y dy. That gives me pi over 2 e to the power 2y from 1 to 2. That gives me what? Pi over 2 e to the power 4 minus e squared. That's easy one. The volume of the solid by rotating. Let me graph the functions about the x-axis, which is good. This is the square root y equals 0, which is the x-axis, x equal to. This is x equal to. Back about this region. And they wanted rotation about what? The x-axis. The x-axis. So this will be my line. So I have r of x will be the function from where to where? From 0 to 2. Very clear, from 0 to 2. What will be the area? Will be pi 2 square root of x square. So the volume will be pi integral from 0 to 2 of what? 4x dx. So it will be pi 2x square from 0 to 2. That'll give me what? 8 pi minus 0, which is 8. Easy. Okay. The volume of this obtained by rotating the region bounded by the curves about the line this. Okay. Let me graph the curves. I have it. Y equal x square and y equal x. So I'm talking about which region? This region. And they want it to be, no, wait a minute. About which line? This is the parabola. This is the line. And about x equal minus 1. So I have it about x equal minus 1. This is minus 1. Okay, this is my axis of revolution. Okay, axis of rotation. Okay, now I'll do the line. This is Now the line, to make it perpendicular, it will be like this. So I need to have the things in terms of y. So this one, I'll write it x equal square root of y. Oh, it's a green one. Okay. It's okay. X equals square root of y, and I have x equal y. Okay, so I have an outer radius, r of y will be what? Will be the one to the right, which is the square root of y. It will be 1 plus the square root of y. Or let me do it this way, square root of y minus 1. So it's 1 plus the square root of small r of y. Very clear, it will be x plus 1. The same idea, x minus 1. Y plus 1. Sorry. Let's write in terms of y. So what will be the area? It will be by this square minus this square. That from where to where? I have it y values from 0, and this is 1. From 0 to 1. So the volume will be by integral from 0 to 1 of this. dy, which is this. Okay. Now we have a little bit strange. I have the formula is what? 0, 0, triangle 0, 0, 1, 0, 0, 1. So I'm talking about this triangle. And the cross sections perpendicular to the x-axis, semicircle. Okay. So I will do the base. The base will be, this will be the base. So the base is what? It should be 2r, huh? Don't forget, it's 2r. And the base will be this line. Or what is this line? I need to find this line. Okay. I need to find the equation of the line which passes through 1, 0 and 0, 1. What will be the slope? It will be 1 minus 0 over 0 minus 1. That will be minus 1. So the line will be y equal, or y minus, let me use this point, y minus 0, so no need, minus x minus 1. So it will be 1 minus x. So this is the line y equal 1 minus x. This is what I need. And that is equal to the base. So r will be 1 minus x over 2. What will be the volume? It will be pi over 2. And what is the area first? What is the area? The area will be pi over 2. This one is square. R square. Okay. So the volume will be what? Will be pi over 2 times 1 over 4. From where to where? From 0 to 1. From 0 to 1 of this square. Now 2 square, 4, I took it outside. So I have 1 minus 2x plus x square dx. That give me what? Pi over 8 x minus x square plus x cubed over 3 from 0 to 1. That give me pi over 8, 1 minus 1 plus 1 over 3. That give me pi over 24. But this is cancelled. So this is my answer. The base of the solid is a region closed by the parabola. Cross section, what is squares? Okay. So I have the parabola. This is x equal 1 minus y square. So this is the parabola. This is my parabola. Okay, perpendicular to the x-axis. Okay, so the base, yeah, since it's square, so the area is the base square. What is the base? Yeah, of course, above the x-axis, it will be like, and the y-axis, So I'm talking about this. Be careful here. Be careful here. Now I need to write it there's of y. So this, it means y squared will be 1 minus x. So y plus or minus square root 1 minus x. So this one is square root 1 minus x, but this one is minus square root 1 minus x. Yeah, because I need to write it in terms of y, in terms of x. So the base will be square root 1 minus x minus square root 1 minus x. That give me 2 square root 1 minus x, which is clear. From where to where? I need it from 0 to 1. Because I need it, yeah, I need the line all the way, covering all of this region. Okay, so the volume will be the integral from 0 to 1, the base square, which is 4, 1 minus x dx. So it's 4 x minus x squared over 2 from 0 to 1. That will be 4, 1 minus half, which is half, that will be 2. So this is the volume is 2. The volume is closed by the regions, this. Okay. Let me graph the region. It's about the y-axis, huh? Be careful, huh? Y equal x squared, y equals square root of x. And it's about the y-axis. This is about this line. So make it perpendicular, I wanted this. So I need the things in terms of y. So I have x square root of y. I need the positive side. I don't need the plus or minus. Because the other side, I don't need it. Here I have x equal y squared. Okay. So now we need to do the calculation. It's about the y-axis. Okay. So I have r of y will be what? Will be the square root of y. Small r of y will be y squared. Since, yeah, I need this minus this. This is the line. Okay. So the area will be by square root of y squared minus y squared. Okay, so the volume will be by, from where to where? For the y values from 0 to 1. Also for the x value, okay. From 0 to 1, that will be y minus y to the power 4 dy. That give me y squared over 2. Y squared over 2 minus y to the power 5 over 5 from 0 to 1. That will be y half minus 1 over 5 5 minus 2, that will be 3 pi over 10, which is okay. A solid has circular base, radius 1. I have a circular base of radius 1. So let me do the graph. I have a circle, radius 1. This is 1. Okay. For cross-section perpendicular to the base are my circles. Perpendicular to the base. So this is perpendicular to the base. Okay. So this one, the upper one will be, yeah, so this, what will be the equation? The equation will be x squared plus y squared is equal to 1. Since I have perpendicular to the base, so it will be in terms of x. So I have y squared is 1 minus x squared. Y equal plus or minus square root 1 minus x squared. So the upper one will be square root 1 minus x squared. And the lower one minus square root 1 minus x squared. So what will be the base? The base will be square root 1 minus x squared minus square root 1 minus x squared. So that gives me 2 square root 1 minus x squared. Don't forget this is equal to 2r because it's the diameter. So r will be square root 1 minus x squared. Now I have a small circle, the area, so the area will be what? Y over 2 r squared, which is this square. And from where to where? From minus 1 to 1. So the volume is the integral from minus 1 to 1, y over 2, 1 minus x dx. This is easy calculation. 1 minus x square. Yeah, this is a square. 1 minus x square. Okay. The square the square root will go with the square. Okay. So I have what? Y over 2 times what? X. First, this is even function. So I can write it y over 2 times 2 integral from 0 to 1 of this. And that give me y x minus x cubed over 3 from 0 to 1. That will be y 1 minus 1 over 3, which is 2y over 3, which is this. Okay. More to go. The region bounded by this. And the line, the line and the curve. Okay. Need to graph it. The points of intersection also. I have y equal x squared plus 1. This is y equal x squared plus 1. I have at x equals 0, it will be 3. At x equal 3, it will be 0. So I have this line. Yeah, it's revolved about the x-axis, and it's about the x-axis. Okay. So where is my line? It will be this. From where to where? I need to find the points of intersection. Intersection points. Equate them. So I have x squared plus x minus 2 equals 0. I have x equal minus 2 and x equal. So this is minus 2 and this is 1. So what is the volume? Yeah, what is r of y? R of x. Capital R of x. The upper one will be the line. And the small one the outer radius and the inner radius. That's small. The inner radius will be what? X squared plus 1. And the area will be by the outer radius square minus the inner radius square. Okay, let me do the calculation. Yeah, it seems to be a lengthy calculation, which is okay. I have y minus 2 to 1. It's from minus 2 to 1. Open this. I have x squared minus 6x plus 9 minus x to the power 4 minus 2x squared minus 1x. So that will be by minus 2 to 1. Let me rewrite it. I have what? Yeah. Minus x to the power 4, x squared minus 2x squared minus x squared minus 6x, a 9 minus 1, which is plus 8 dx. Yeah, now it's a matter of calculation. That will be what? I minus x to the power 5 over 5 minus x cubed over 3 minus 3x squared plus 8x. All of this from minus 2 to 1. Okay, by minus 1 over 5 minus 1 over 3 minus 3 plus 8 minus, substitute minus 2, that will be what? 2 to the power 5 is 32. That will be 32 over 5. What a number. I don't know why I want it this way. Okay. 32 over 5 minus 2 with this one, that will be minus 8 times minus, that will be plus 8 over 3. Okay. Minus 12 minus 16. That give me what? By minus 1 over 5 minus 32 over minus 33 over 5. Minus 1 over 3 minus 8 over 3. That's minus 3, which is good. Minus 3 plus 5, 8. This is plus 5. And this is 28 with the minus. That will be plus 28. So it will be by, hopefully make the correction, the calculations correct. 28 plus 5. That will be 33 minus 3. That will be 30 plus 30. So we have y 150 minus 33 over 5, which is 117 over 5, which is this. Yeah, correct. Good. The volume of the solid formed by revolving the region bounded by, okay, about the line y equal 1. Okay, so let me grab the region first. That will be the region. 2 minus x squared, so it is 2, like this. And y equal 1. Y equal 1 somewhere here. That is y equal 1. And I want it about the line y equal 1, about this line. Okay. So yeah, this is the axis revolution. So this is will be my strip or my line. Okay. So what will be, it will be in terms of x. And they have only a disk because it will be this one, because this is axis revolution right away. So I have r of x is what? Is the function minus 1. And that give me 1 minus x squared. And from where to where? That is from when y equal 1, I equate this. equal to 1. This is the point of intersection. It means what? X squared equal 1. So x equal plus or minus 1. So these are minus 1 and 1. So the volume will be by minus 1 to 1 of this square. Because this is the area. The area will be by, yeah, square bx, which is this one. Okay. The volume is still having the base on this, bounded by this, I have equatorial triangle. He gave me the area, which is I know it. Okay. So let me graph the region first. The region is what? I have the two lines. The first one, I have x equals 0, it is 1. And at x equal 2, it is 0. So this will be my first line. The second line, at x equals 0, it is minus 1. This is 1. But at x equal 2, it is 0. So it will be the same. Here, they intersect here. Good. And x equals 0, which is the y-axis. I have the y-axis here, so I'm talking about this region. Okay. Equatorial triangle. I need to find the base now. What will be the base? The base will be this, which is the upper line, which is 1 minus x over 2 minus 1 plus x over 2. That gives me what? 1 minus 1, that is 2, minus x over 2 minus x over 2, 2 minus x. And the area will be what? Square root 3 over 4, the base square. That will be the area. And from where to where? From 0 to 2. Okay, so the volume from 0 to 2, this area, square root 3 over 4, 4 minus 4x plus x. Let me take square root 3 over 4 outside. I have what? 4x minus 2x squared plus x cubed over 3 from 0 to 2. That gives me square root 3 over 4 of what? 8 minus 8 plus 8 over 3. That gives me what? This is cancelled. 8 with 4 go 2. That will be 2 square root 3 over 3, which is this one. More problems. We have squares in this case. So let me grab the region first. I have y equals sine x. These are the curves, y equals sine x up to y, from 0 to y. This is what I want. And they have x equals 0, x equal y. X equals 0 is the y-axis, x equal y, and the x-axis. So I'm talking about this region. Okay. What we want? Squares. So I need the base. So the base, perpendicular to what? The x-axis. So this is what I have. So the base will be what? The base will be sine x. And the area will be the base square, which is sine square x. From where to where? From 0 to y. So the volume, 0 to y, sine square x dx. That will be the answer. This one done before. No, by mistake. Okay. Done before. No, you can check. It was done before. Okay. Next one. Okay, I'll try to finish this section. Using the cross sections, the volume of the solid obtained by rotating this, the region boundary. Okay. Let me have the functions. Y equals square root of x. Y equal x. About the line, y equal -1. This is minus 1. So this is my conclusion. Okay. So it will be, and yeah, so it will be the line. That will be my line. So you have r of x will be what? The upper, which the outer radius, which is square root of x minus -1, which is 1 plus the square root of x. Small r of x, that will be x minus -1, that will be 1 plus x. Okay. And from where to where? From 0. This is the point of section is 1, very clear. So the volume will be then by, the area. What is the area? Here, do it this way. By 1 plus the square root of x square minus 1 plus x square. So that will be, yeah, from 0 to 1, this one, 1 plus the square root of x or x, well, square root of x plus 1 is the same, minus x plus 1 squared. Don't forget the x, which is this. Okay. Next one. So I have y equal x squared, which is this parabola, and x equal y squared, which is this parabola. And the region, yeah, bounded by these two curves. And about what about the line y equal 1, which is this one, the y equal 1. How about this? This is 1. Huh? Y equal 1, x equal 1. This is 0. Okay. So I have the line, about the line y equal perpendicular to this, so I have it in terms of x. I have the things in terms of x. Okay. So I have now the outer radius, be careful now, the bigger one, r of x will be this one, which is 1 minus x squared. Yeah, also we need to be careful. This means y equal plus or minus square root of x. I need only the positive one, because this one, y equal square root of x. I mean this one. That makes it with y equal 1. This is y equal 1. This one, no, not this one. This one is y equal square root of x, the positive side. Okay, so r of x will be what? 1. The upper one, the bigger one, I mean, 1 minus x squared. It will be 1 minus x squared. The inner radius will be 1 minus square root of x. Okay, and the area will be by 1 minus x squared minus 1 minus square root of x squared. Okay, the volume will be by integral from 0 to 1 of this. Open it. 1 minus 2x squared plus x to the power 4 minus 1 plus 2 square root of x plus x dx. Yeah, lengthy calculation. Good. 1 minus 1 cancel. Good. So that give me what? Minus 2 over 3. Don't forget the by as usual. Minus 2 over 3 x cubed plus x to the power 5 over 5. This one is what? 2 over 3 x to the power 3 over 2 plus x squared over 2 from 0 to 1. That means it's y minus 2 over 3 plus 1 over 5 plus 4 over 3 plus half. Yeah, that will be what? 1 over 5 plus 2 over 3 plus 1 over 2. Wait a minute. This is minus, sorry. This is minus x. This is minus x. This is minus. This is minus. This is minus. Don't forget the by. So that will be by over 30. We have 6 plus 20 minus 15. So that'll give me what? 11 pi over 30, which is this. The volume of the solid obtained by rotating y equal ln x, y equal minus 1 and 1. Okay. Y equal ln x. This is y equal ln x. This is 1. And I have the line y equal 1 and y equal minus 1. But is it this? It's open a little bit, huh? By x equal minus 1. This is my axis of rotation, which is minus 1. This is 1. This is minus 1. Be careful here. You need to figure out one thing. Since I have ln x, means x is positive. So I'm talking about this region. Yeah. Okay. So now I need to do the line. It's perpendicular to this, so I have it in terms of y. Okay. So I need to change everything in terms of y. That will be what? X equal e to the power y. So I have the outer radius is what? Is e to the power y minus 1, which is plus 1. And the inner radius will be 1. Minus 1. But 0 minus 1, which is 1. Okay, from where to where? The x values from minus 1 to 1. Huh? Well, the y values, I mean. And the area will be by this one square minus this one square. So it will be my volume. It will be by minus 1 to 1. This one square, which is e to y plus 2 ey plus 1 minus 1 dy. So that will be by minus 1 to 1 e to y plus 2 ey dy, which is this one. Okay. Y equals 6 minus x squared and y equal 2 about y equal 2. Okay. So I need this parabola. 6 minus x squared. So this is 6 minus x squared. So this one. Y equal 2. What is y equal 2? When y equal 2, x is what? Yeah, by the way, this is square root of 6. This point is square root of 6. So equal to somewhere here. That is y equal to. And about the line y equal to. We want to do the revolution about this line. And I'm talking about the region bounded by this curve. Okay. I'm talking about this region. And this is the line perpendicular to this. 4 minus x squared, that will be the disk. And from where to where? For the x value, it will be from 0. And what is this point? At y equal 2 equals 6 minus x squared. So I have what? X squared equal 4, so x equal also minus 2. So this value is 2. And by the way, the area will be pi times this square. So the volume will be pi minus 2 to 2, huh? Yeah, I need all of it, huh? I need all of this from minus 2 to 2. This is minus 2 to 2, not from 0, sorry. Yeah, because I need the full region. Yeah, I want this, all of this region. Yeah. Okay. That's minus 2 to 2. And they have what? Pi, I have 4 minus x squared, all squared dx. This one, since this is even function, I have 2 pi from 0 to 2 of this. And this is that. The value is obtained by rotating the region bounded by the curve. Okay. Need to grab the function. X equals square root of y. X equals square root of y, which means y equals square root, y equal x squared, which is just the positive side of this. So I need this. Okay. X equals 0. X equals 0, the y-axis, and y equal 1. This is y. So I'm talking about this region. About what? About y equal 1. Okay. So this will be my line. Oops. This will be mine. So it's what? Yeah, I need to write in terms of x, huh? So I have y equal x squared. So that will be r of x will be 1 minus x squared. That's it. And this is the axis rotation is okay, is y equal 1. Oh, so the area will be by 1 minus x squared. Okay, from where to where? From 0 to 1 this time. From 0 to 1. So the volume will be by from 0 to 1, 1 minus x squared, which is 1 minus 2x squared plus x to the power 4 dx. Do the calculation. X minus 2x cubed over 3 from 0 to 1. I have by 1 minus 2 over 3 plus 1 over 5, which is by times what? 15, 5 minus 10 plus 3, which is 8 pi over 15. Look at this. The volume of the solid generated in the region bounded by the curve. Okay. Let me grab the functions or the curves. I have what? This is parabola open to the right. Okay. And they have y equal 4. Y equal 4 will be somewhere here. This y equal 4. X equals 0, which is the y-axis. So I'm talking about this region. About this region. About what? About the x-axis. About the x-axis. Okay. So my line will be like this, perpendicular to this axis for motion. So I have r of x will be 4. Yeah, I need to write this in terms of x. So in terms of y. So I have what? Y equal plus or minus square root 2x. And they want the positive side. So I have a small r of x will be square root 2x. Because I need this. Which is y equal square root 2x. I don't need this. And y equal minus. I need the positive side. So what will be the area? Will be by 4 square minus 2x square. Square root of 2x square. And from where to where? That will be 0. I need this point. Equate these two. Yeah, at what x value? Put 4 here. And I need to find the intersection of these two. So plug 4, I have 16 equal to x, so x equal 8. So this will be 8. So the volume by from 0 to 8 of this, which is 16 minus 2x dx. That give me by 16x minus x squared from 0 to 8. That give me by what? 16 times 8 minus 8 times 8. Yeah, I can do it this way. That give me by 16 minus 8. You can take 8 common factor. You can play with it this way. That will be 8 minus 8, 64. 16 minus 8, 8 times 8, 64. Okay. Lot of calculation. I think we did most of the ideas, if not all. I have y equal x cubed. This is y equal x cubed. Y equal 1. This is y equal 1. X equal 0, which is the y-axis. I'm talking about this region. Okay. Perpendicular to the axis, squares. I have a square. So I need the base. It will be like this. So the base will be what? The base will be 1 minus x cubed. And the area will be the base square, which is 1 minus x cubed square. From where to where? From 0, when x equal 1, when y equal 1, x equal 1. 0 to 1. So the volume will be integral from 0 to 1 of this, which is 1 minus 2x cubed plus x to the power 6 dx. That give me x minus 2, x to the power 4 over 4, which is x to the power 4 over 2, plus x to the power 7 over 7, from 0 to 1. That will be 1 minus half plus 1 over 7 over 14. That will be 14 minus 7 plus 2. That will be 9 over 14. Let us be the solid multiplied the region bounded by this. C and D are two different numbers in the interval that divide the solid. That's a little bit complicated. Yeah, into 3 parts of equal volume. And C squared plus D squared is what? Yeah, it seems to be a question from the book also. Okay. Solid by forming this. Let me see what's going on. This will be my function. Y equals square root of x. Y equals 0, the x-axis. X equal 1, x equal 3. Talk about this region. Okay. And what he's talking about, I have here C, and I have here D. That will make these 3 places 3 equal volumes. Okay. So what I will do, this is from 1 to 3. This is from 1 to 3. Yeah. Let me grab this C and D with a different color. So this C, this is D. C and this is D. Let me go back to no. Okay. Now I have this is my strip. This is my line. Okay. I need first to do the full volume. And I know from 1 to C it will be 1/3 of that. And C to D it will be 1/3 of that. That's it. Yeah, so I'll do it in a step. So V, by the way, what is the R of X? Very clear, the square root of X. So the area will be by X, by square root of X all square, which is easy one. So the volume will be what? Integral from 1 to 3, had the full volume. 1 to 3 of X dx. Don't forget the by. X dx. Okay. And that give me what? It will be by X squared over 2 from 1 to 3. That will be by 9 over 2 minus half, 8 over 2, that will be 4. 9 over 2 minus half. That will be 8 over 2, which is 4. Now, the volume, which is by from 1 to C, X dx, that should be 1/3 of this, which is 4 pi over 3. So don't think about the pi, do the calculation of from 1 to C. Pi will be cancelled, don't care about pi. That give me what? X squared over 2 from 1 to C should be 4 over 3. So I have what? C squared over 2 minus half equal 4 over 3. So I have C squared over 2 equal what? Take half to the other side. I have what? 1 over 2 plus 4 over 3. Which is what? 11 over 6. So C squared, which I need, will be 22 over 6, which is 11 over 3. I get C squared. I'll do the same now between C and D. I know C now. So what will be the integral? Or I can do D3. Yeah, maybe better. No need to be bothered with, because it will be the same. So I know the V, which is, call it V1, V2, V3, which is by from 3 to D, from D to 3, sorry, D to 3. X dx, that should be still 4 pi over 3, 1/3 of this. So I have X squared over 2 from D to 3 times pi. That will be by 9 over 2 minus D squared over 2. Cancel the pi. No need for the pi, because it will be 4 over 3. Yeah? So I have D squared over 2 is 9 over 2 minus 4 over 3. Is it? Yeah. Which is what? 27 minus 8, that will be 19 over 6. So D squared will be 18 over, that will be 19. That will be 19 over 3. So that implies C squared plus D squared will be 30 over 3, which is this one. Yeah, good question. Yeah, good. Okay. This is the function. Right, to finish. 2 over 1 plus x is from our book, okay? 2 over 1 plus x, it will be, yeah, I have it minus 1. I have the asymptotes. Do something like this. Okay, y equals 0 to the x-axis, x equals 0, the y-axis, and x equals 0, and x equals 4. So I'm talking about this region. Okay. And about the line, y equals 4. Yeah, y equals 4. This is my axis over function. And he said it's k times this, find k. Okay, let's just find it, and then we can find k. It will be, this is my strip or my line. So I have r of x, the bigger one, this is 4. It will be 4 minus 0, which is 4. Small, and it will be what? 4 minus the function. 4 minus 2 over x plus 1. And the area will be by 4 square minus the function, 4 minus the function square. And from where to where? That is from 0 to 4. Think about this. So volume will be by integral from 0 to 4. Integral from 0 to 4 of this, which is what? 16 minus 16 minus 4 times 2 times 2, 8, 16 over x plus 1 plus 4 over x plus 1 square dx. So 16 minus 16 gone, minus 16, that give me, that will be by 16 ln x plus 1. This is minus 4, so it will be minus 4 over x plus 1, just an integration from 0 to 4. That will be by 16 ln 5, good, minus 4 over 5, 4 over 5, yeah, minus. Now, if I put 0 here, I'm getting 0, and I have minus minus 4. That give me by 16 ln 5 plus 4, which is 20 over 5. 4 minus 4 over 5. This is 20 over 5 minus 4. That will be 16 over 5. By 16 ln 5 plus 16 over 5. Minus. Is it plus or minus? Did I do a mistake somewhere? That will be plus 4 over x plus, sorry. That is minus times this, so this is plus. So I have plus 4 over 5 minus 4, so that will be the opposite. Minus 4 plus this, so this is minus. Yeah. So I can take 16 by common factor. I have ln 5 minus 1 over 5, which is this one. So k equals 16 by. Yeah, you need to be careful always with the calculation. The volume, the region bounded by. I want to finish this 7.2. I'm taking a little bit long video, but just to finish this 7.2. Y equal x cubed. Y equals 0, x equal 2. Is x equal 2? And about the line, x equal 4. About the line, x equal. This is my axis of revolution. Okay. So what will be my place. This is my place. And I want the, oh, no, I want it to be the other way. It will be like this. Since it's perpendicular to the axis of revolution, which is x equal 4 in this case. So I have capital R of y, the outer radius, will be 4 minus the function. Yeah, I need to write this in terms of y. It's xy to the power 1 over 3. So it's 4 minus y to the power 1 over 3. And the inner radius will be 4 minus, it will be what? Yeah. This is the outer, this is the inner. The inner is 4 minus 2, which is 2. Okay. So the area will be by this square minus 2 square. Okay. Yeah. So now let me, and from where to where? Y values. I'm talking about the Y values. This is 0. If x equal 2, if x equal 2, y will be 8. So this is 8. Y values. 0, the volume will be by, yeah, from 0 to 8 of this. 4 minus 1 over 3 square minus 4 dy. That give me what? Y from 0 to 8, 16 minus 8 y to the power 1 over 3 plus y to the power 2 over 3 minus 4 dy, which is 12. So I have by 12y minus 8, add 1 times 3 over 4, y to the power 4 over 3, add 1 again, plus 3 over 5, y to the power 5 over 3. This is gone with this, that's 12. This is from 0 to 8. Yeah, method of calculation. By 12 times 8, that will be 96. Here I have what? 8 cube root of 8 is 2. 2 to the power 4 is 16. 16 over 4, that is 4. So 4 times 12, 4 times 3 is 12. So I have 12 times 8, which is the same, which is 0 now. This one, cube root of 8 is 2. 32 times 3, 96 over 5. This one is the same, so I cancelled. So I have 96 by over 5, which is this one. A bit lengthy, but it's okay. The volume of the solid obtained divided the volume, the region bounded by the graphs of this, okay. Let me do, now I have 10. But he's very careful when he did it, okay. This is 10. I have minus plus pi over 2. Minus pi over 2. Now the 10x. But I want it to be, yeah, so I have everything is okay. Continuous, no problem. And this is pi over 4. And the x-axis, I'm talking about this area. Okay. So my line will be this. So I have r of x. It's revolving about the x-axis. Huh? Okay. R of x will be what? Will be tan x. And the area will be pi tan x squared. That will be. From where to where? From minus. Yeah. It will be from 0 to pi over 4. Why is that? No, it will be from minus pi over 4 to, yeah, it will be minus, from minus the volume will be pi from minus pi over 4 to pi over 4 of what? Tan square x dx. It's an even one, so that will be 2 pi from 0 to pi over 4. Tan square, I can write it as secant square minus 1 dx. That give me what? 2 pi of what? What's the integral of secant? That will be tan x minus x from 0 to pi over 4. That will be 2 pi 1 minus pi over 4. Tan 0 is 0, خلاص. That I can take pi common factor. I have 2 minus pi over 2. What is this? Okay. Yeah. Okay. Let me finish it. Oh, yeah, divide the solid. 21. Solid from the revolving the region bounded by this. Y equals square root of x. Y equals square root of x. Y equals 0. X equal 2. X equal 4. You want to divide the solid into 3 parts. I'll do the same idea like what we did before. So I have, this is C, this is D. Yeah. This is would be my step. Put it any place, no problem. Okay. It's about the x-axis. Okay. So R of x will be square root of x. The area will be pi square root of x squared. So we'll find the full volume, which is what? From where to where? From 2 to 4 by x dx. Okay. So I have pi x squared over 2 from 2 to 4. If we do the calculation, that will be what? 16 over 2, which is 8 minus 2. That would be 6 pi. Now, from D to C, from 2 to C, that will be 1/3 of this. So the integral from 2 to C, it will be 1/3 of that, which is 2 pi. So now we need to find C. X dx, the same function. That will be x squared over 2 from 2 to C. That will be c squared over 2. Yeah, times pi, cancel the pi, because the pi will be taken as a common factor. Here I have pi. So pi cancelled. So that implies x squared over 2 from 2 to c is equal to 2. So I have what? C squared over 2 minus. This is 4 over 2, that is 2 equal to 2. So c squared equal what? 8. So c equal to square root of 2. I will not take the negative because it's important. So that will be c. Okay, the same idea. 2 pi v3, which is now from d to 4. X dx times pi, which is x squared over 2 from d to 4. So by cancelled, that implies, and we have what? X squared over 2 from d to 4 equal to 2. So I have 16 over 2, that will be 8 minus d squared over 2 is equal to 2. So I have what? D squared over 2 is equal to 6. So d squared equal 12. So D equal to square root of 3. This is this. So this is my answer. I'll take the plus, I'll not take the minus. Okay. Solid obtained by this. Let me grab the function. The region boundary the graphs of this equation, easy ones. Yeah, this is the questions from the book. Y equal 3. This is y equal 3. And they wanted about the line y equal 4. This is my next option. And this is my region. I have the y-axis, x equal. Okay. So what will be my line? This will be my line. Okay, I have r of x, capital R of x, the upper one, which is 4 minus x. Small one will be 4 minus 3, which is 1. So the area will be by this one minus 1 square. So the volume from where to where? That is from 0. I need this with y equal 3, x equal 3. So it's from 0 to 3 by, open this, that will be 16 minus 2x plus x squared minus 1 dx. That give me by 15x minus 15 minus 8x, sorry, this is 8. That will be minus 4x squared plus x cubed over 3. And that from 0 to 3. Okay. That give me what? Pi times 345. 3 squared is 9 times 4 minus 36. 27 plus 9. That will be what? 45 plus 9, that's 54 minus 36, that will be 18 pi. 18. Which is this one, huh? Good. I don't need to find that. Okay. Divide by the region by this. Squares. Good. Squares are easy. X-axis also easy. Okay. So I have the region. Y equal x plus 1, which is at 0, it will be 1. And at minus 1, that will be the line. And y equal x squared minus 1. And that will be the parabola. Which I think it will pass with this one. Okay. So I'm talking about this area. The squares. So I need the base. So this is would be. So the base will be what? The line minus the parabola. Minus x squared plus 1. That will be 2 plus x minus x squared. And what is the area? It will be this square. That will be the area. So from where to where? When they will intersect, x plus 1 equal x squared minus 1. So I have x squared minus x minus 2 equal to 0. I have x minus 2 of x plus 1 equal to 0. So I have this is minus 1 and this is 2. So the volume will be from minus 1 to 2 of this square. How to do this square? I can take this as 1 and do the other one. So I have 2 plus x all square minus 2. 2 plus x times x square plus x square square dx. That give me what? Minus 1. Minus 1 to 2. Open this. 4 plus 4x plus x square minus 4x square, صح? 2 times 2 times x square minus 2x cubed plus x to the power 4 dx. Now let me join the things. I have x to the power 4, this, x cubed, I have only this, minus 2x cubed. This is the x square. So that gives me minus 3x square plus 4x plus 4 dx, which is this one. The last one. Yeah. Possible book, I think. What will be the region? I have y equal x squared plus 2. X squared plus 2, that is the parabola. And they have the other one is 10 minus x. So it's something like this. It's about the line y equal minus 1. This is y equal minus 1. Okay. I want it to be perpendicular to that. So I have in terms of x. Okay. So what is r of x? R of x will be the upper one, which is the 10 minus x squared minus 1. That give me 11 minus x squared. Small r will be the lower one, which is x squared plus 2 minus 1. Sits up to half. This is my axis of revolution. So that give me x squared plus 3. Okay. Yeah, that will give me a hint. This is my solution, but it's okay. Let me do the calculation. A will be pi of this 11 minus x squared minus x squared plus 3 squared. Okay, from where to where? I need to equate them. X squared plus 2 equal 10 minus x squared. So I have 2x squared equals 8. So x squared equals 4. So x equal plus or minus 2. Okay, so it's from minus 2. This is minus 2 to 2. So the volume will be by minus 2 to 2. All of this. 11 minus x squared minus x squared plus 3 squared dx. And everything in terms of 2 pi, and this is even. So that will be 2 pi from 0 to 2 of this. And yeah. So this is my answer. I'll stop here now. The remaining, if I have some questions from the book, but I will stop the recording. Thank you.